Hello, this is AMET 104 lecture recording week 12.2. So today we're going to go over chapter 16.4, the examples from this chapter 16.4. Last time we went over the materials and we already did some examples and we also defined the notion of expectation and weighted average, which are essentially the same thing. So before I go over the examples, let me first go over the definition again. Expectation, and this is essentially the same as weighted average. And for suppose X is a variable that takes on numerical values let's say x1, x2 to xn with probabilities P1, P2, all the way up to Pn. So here probability is the same thing as weight. It means that how likely it is to happen, and respectively, meaning that x1 has probability of P1, x2 has probability of P2, and so on and so forth. And we have with P1, P2, and if you add all the probabilities, we know that this has to equal to 1. Then the expectation or in other words, you can say expected value they're all the same thing, of X is given by the following. P1 multiplied by X1 plus P2 multiplied by X2 plus all the way up to P sub n multiplied by X sub n. So that was essentially what we did last time. So for the first example, let's do something that's you guys are very familiar with. Let's say find the expected value of rolling a die. So what does it mean? What does this problem ask? So basically it's asking, if you roll a die, what number is it going to land on? It's a really weird question because if you roll a die, we all have equally likely probability to get any number from 1 to 6. But what essentially this means is that if you roll it several times, if you roll it a lot of times, the average of the numbers would converge to this specific number, and that's what it's trying to find. That's what the expected value is. Same thing as flipping a coin. You have an equally likely probability of flipping heads or tails, but if you flip, let's say 5 times, you're not gonna land exactly 2.5, 2.5 times of each, but the expected value would be 2.5. So in that sense, how you would do it is in scores, you have 1, 2, 3, 4, 5, and 6. And you can say the probability is 1/6 for each of them. And I'm sure we can all agree with that. Then simply the expected value, you can say it's for 1/6 multiplied by the numerical value 1, and you're adding 2 multiplied by 1/6, and you're also doing 1/6 multiplied by 3, 1/6 multiplied by 4, 1/6 multiplied by 5, and lastly 1/6 multiplied by 6. And if you do all the calculations, you should end up with 3.5. So essentially, this doesn't mean that you're going to land on 3.5, and that's impossible because there's no such number as 3.5 when rolling a die. But this means that if you were to roll it infinite number of times, your average score where you will end, the average score that you'll get at the end will be 3.5. That's what the expectation is. So oftentimes, if you study statistics, oftentimes the expectation and the average, the words are synonymous, not all the time, but oftentimes people use interchangeably. So let's now go over to another example. Suppose this is another class that you're in, and you're being graded upon test 1, test 2, and you also have test 3. And you also have quizzes. You have paper. And you also have final. And the weight of each category is 15% for test 1, 15% for test 2, and same for test 3. For the quiz, let's say it's 10%, and for paper, it's 25%. And let's say final is worth 20% of the entire grade. And possible points are 100 for each quiz, each test. Let's say for the quiz, you have total of 120 because there are only multiple quizzes. And for the paper, let's say it's also 120, and for the final, let's say it's 200. And let's now talk about your score. So your score for test 1, you received 99. For test 2, you got 80. For test 3, 88. Let's say for quizzes, you got 90. For paper, you got 105. And for the final, let's say you got 176. And here, the question is to find your average score in this class. So your total score in this class. So it's actually the same question as one of the problems that we went over last class. The first step here is to find the percentage of your score. So obviously, if you're graded out of 100, simply you got 99%, 80%, 88% for the tests. But obviously, you need to do some calculations with the quizzes, papers, and final because they're not out of 100. So let's first find the percentages of your score. Percentages, and here for test 1, we know it's 99%. For test 2, it's 80%. Test 3 is 88%. And for the quizzes, it'll be 90 over 120, and that is 75%. If you got 105 over 120, that is 87.5. And lastly, if you got 176 over 200, that's 88%. So you now actually have the numerical percentage values for each category here. So test 1, test 2, and everything, we have it in percentage. So with the weight, let's now convert the weights we have into decimals. So we know that the weight in decimal, or essentially this is the same thing as the probability that we did in the expectations. It's just because we're in different contexts, we're just using different words, different terminology, but it's really the same thing. So the 15% of the weight, or in other words, the 15% probability, but probability, using the word probability here, is not very appropriate because we're not playing a game of chance. So the weight in decimal, so 15% here is 0.15. And same thing as here, same thing as here. And for quiz is 10%, so it's 0.1. For paper, it's 0.25. And lastly, for the final, it's 0.2. And as you can see, if you add everything up in the weights in decimal, it should add up to 1. So then you can find the average, which is weighted average. You can simply multiply the percentage by their your score and percentage by their respective weight in decimal. So simply it will be 0.15 multiplied by 99 plus 0.15 multiplied by 80, 0.15 multiplied by 88, 0.1 multiplied by 75. You keep adding 0.25 multiplied by 87.5, and lastly 0.2 multiplied by 88. And if you add all these up, obviously you have to calculate each of them in brackets first, in the parentheses first, and by adding everything up, you get 87.03, and the unit is percent. So this means by this calculation, you can see that you received 87.03% in this class. And that's all we did to calculate this. Let's look at next example. So let's say at a high school, the student body is divided by age as follows. So let's say we have 7% of the students are 13. We have 21% of the students are 14. 18% of the students are 15. 19% is 16. And let's say 17% is 17. And the rest are 18 years old. So this is the age column, and this is the percentage. So the problem here is to find the average age of a student in this school. So average age of the students, obviously, as you can see, we're given a numerical value for each age, and we also have percentage for each age. So essentially, we are simply using the weighted average in this case. But as you can see, we're not given the percentage for 18-year-olds. So let's first complete this calculation. So we know that all the percentages has to add up to be 100. And if you add 7 plus 21 plus 18 and 19 and 17, you will end up with 82. So this total is 82. This essentially means rest of the students has to be 18. So you have 18% who are 18-year-old. So let's now find the average age. So the first thing you have to do is to convert this percentage into the weights. So you can simply say that for decimals, weight in decimal, you have 7% is 0.07, 21% is 0.21, 18% is 0.18, 19 is 0.19, and we also 17% 0.17, and lastly for the 18% we have another 0.18. Then the weighted average, you can simply multiply the numerical value of the age by each weight in decimal. So simply it is 0.07 multiplied by 13 plus 0.14 multiplied by, 0.21 multiplied by 14, 0.18 multiplied by 15, 0.19 multiplied by 16, and 0.17 multiplied by 17, and lastly 0.18 multiplied by 18. And by putting this into calculator, we can conclude that the average age of the students is 15.72 years. So these are really repetitive work. You're just put in different context. They just trick you with different words, different terminology. However, the only thing that you need to get out of it is how to interpret the numbers and just how to put it into the formula that we already know and we've been using over and over again just for this chapter. So for that, I'm just going to do one last example before I let you go. I know it's a very quick class, but it's totally fine. I think that's enough material that you need to consume for this chapter. So this will be the last example of the day. So let's say a box contains 16 $1 bills, and you have 9 $5 bills, and you have 8 $10 bills, and 5 $20 bills, and lastly, let's say 2 $100 bills. It's kind of weird not to say this, but let's put the multiplication sign there so it makes more sense. So you have in a box 16 of $1 bills, 9 of $5 bills, and so on and so forth. And the question is, you blindly reach into the box and draw a bill at random. What's your expected value? Of your draw. So again, it's the same type of problem in a different context. So what's the first thing you need to do? You need to find the probability of drawing each bill. In order to do that, to find a probability, we need to first find the total number of bills. So we can see the total number of bills is simply, you can say the total number of bills. You can simply say 16 plus 9 plus 8 plus 5 plus 5 plus 2. And we can confirm that this is 40 bills. So we have total of 40 like 40 single bills. Then for the weight, in other words, the probability, is given as 16 over 40, which is essentially 0.4. And we have 9 over 40 is 0.225. And 8 over 40 is 0.2. And we also have 5 with a $20 bill, so 5 over 40 is 0.125. And lastly, 2 over 40 is 0.05. And make sure everything adds up to be 1. And the probability here is 0.04 is for $1 bills, 0.225 is for the $5 bills, and so on and so forth, respectively. So now that we have the probability of drawing each bill, we are actually all set. We can simply now put it into the expectation formula. So the expected value, the E, you can simply say you have 0.4 probability of getting $1 bill. Let me put a dollar sign there so we are in context. And we have 0.225 probability of getting $5 bills. And we have 0.2 probability of drawing $10 bills. And we have 0.125 for the $20 bill. And lastly, we have 0.05 for the $100 bill. So by putting this into calculator, and if you put this correctly, you should end up with 11.03. So I've emphasized this numerous times before. This doesn't mean that when you draw a bill out of this box, you will draw exactly $11.03. Obviously, that's not possible because there's no such thing as $11.03 bill. But what this means is that if you were to draw a single bill out of this box multiple times, if you were to do that repeatedly for, let's say, infinite number of times, the average value of the bill, sometimes sometimes you would draw a $100 bill, sometimes you would draw a $20 bill, sometimes you only draw a $1 bill. But if you average those all out, the expectation, or in other words, the average value that you draw will converge to $11.03. So even though this number may not make any sense, saying that, oh, your expected value of your draw is 11.03. Obviously, that's not possible, but you got to think of it in a probabilistic context. It's not literal number that we're talking of. It's more of a probability that we're more interested in. Okay, so I think that's all for today. If you have any questions or comments, please email me. And I hope you have a great rest of the day.